Hello everyone. In today's video, we will discuss even and odd functions. So, let's start it. First, we will look at the definition of an even function. A function is said to be even if f of minus x equals f of x, for all x belongs to domain of f. If a function satisfies this condition, then it is called an even function. Consider a function f of x equals x caret 2 is an even function, then it must fulfill the given condition. To check this, we will replace x with minus x and see the condition holds. If it does, then the function is even. So let's examine it, as we have checked x squared is an even function because it satisfies the condition f of minus x equals f of x. Now let's move to the graphical method to see how we can examine a function. Is it even or odd? For this, we first plot the graph. You should see a graph of x squared on the screen. The graph is symmetric about the y-axis. If the branch on the right side of the graph are identical to that on the left side, then we call such a function an even function. For example, if you look at the graph, you can see that the branch on the left and right off the y-axis are the same. Another example is the cosine function. When you plot the cosine function, it is also symmetric. The yellow graph you see represents the cosine function, and it is also symmetric. One property of an even function is that if we add a constant to an even function, such as x squared, the function remains even. For instance, if we add a constant, say 1 to the y value of this function, it will still remain even. If we plot the graph of x squared plus 1, it will be symmetric about the y-axis because it belongs to the same family of parabolas. Similarly, if we subtract a constant such as 5, the graph will shift along the negative y-axis, but still it's even. Now moving towards odd function. First, we define an odd function. A function is said to be odd if f of minus x equals minus f of x, for all x belongs to domain of f. If a function satisfies this condition, then it is called an odd function. For example, consider a function x cubed. If f of x equals x caret 3 is an odd function, then it must fulfill the given condition. To check this, we will replace x with minus x and see if the condition holds. As we have checked, x cubed is an odd function because it satisfies the condition f of minus x equals minus f of x. Now we will use the graphical method or use a graph to see how x cubed is odd. The function that is odd is basically symmetric about the origin. For example, if this is our origin, then the graph on one side of the origin is exactly the same as the graph on the other side of the origin. However, for even functions, as I mentioned earlier, if you add any number to the y value, it remains even. But this is not the case for odd functions. For instance, if you add minus 1 or 1 to an odd function such as x caret 3 plus 1, the graph of x cubed plus 1 would be different from the graph of x cubed.